Alright, we're going to do what we just did before. Take a look at this. Our base here is E. E is 2.7. This is going to be a growth. And remember, growth tells us that the right side will be going away from the asymptote. Alright, the domain, negative infinity to infinity. Asymptote, I'm going to go there next. There's nothing added, so it's going to be y equals 0. Go ahead and graph that. My range, I'm going to look at my a value. My a value is positive, which means that my graph will be above the asymptote. So it'll get close to 0 and then go up forever. Alright, there's been no shifting, nothing added or subtracted, so pretty much that's kind of like a parent function, just with a 2 in front of it. So I'm going to plug in 0 for x. So really, here's what we're doing. We're doing 2 times e to the 0 power. Anything to the 0 power is 1, so that's 1. 1 times 2 is 2. So my first point is 0, 2. The next point I'm going to look for here is I will plug in 1. That's just an easy one to do. You can plug in any number you want. So 2 times e to the first. I'm going to definitely use my calculator here because that's 2 times 2.72, so it's going to be about 5.4. And again, you can always use your table function as well. Alright, I don't have to worry about any kind of shifting. This is a growth, so I know that the right side is going to be going away from the asymptote. You look here, it's going away, which means that the left side is going to have to get very close. Let's try another one. The next one has some shifting with it, so I will do my parent function first and then I will shift. Take a look. Let's start with our base here, whatever has the exponent. It's e to the positive exponent, which means that this is going to be a growth again. Again, the right side is going to be going away from the asymptote. The domain is negative infinity to infinity. The asymptote this time is y equals 2. I'm going to graph that. And then my range I will find by looking at my a value. It is negative, which means this is going to be, the graph will be below the asymptote. So it'll go down to negative infinity, go down forever, and then it'll get really close to the asymptote. 2. Alright, so we do have some shifting here. If you look here, I'll do my shifting in green. We've got that plus 1 and we've got this plus 2. The plus 1 is going to make the graph shift to the left 1. Look like a 1. And then it's also going to go up 2. So I'm going to do that. That'll be my last step that I do. So the first thing that I do, though, is I'm going to graph y is equal to negative 3 e to the x. So I'll plug in 0. E to the 0 is 1. 1 times negative 3 is negative 3. So there's my first point. The next point that I'm going to look for, I'm going to plug in 1 for x, so e to the x is 2.7. Again, grab your calculator, you don't want to not use this. And then do 2.7 times negative 3, and I got about negative 8.2. So I'm going to plot that point. Alright, so I have my ugly points on there. I know they can't do a good job with this. But there's the 2 points, 0, negative 3, and 1, negative 8.2. And what I'm going to do now, I said I'd do this last, is I'm going to shift both of those left 1 and up 2. Remember, it's left 1 because it's always the opposite of what it looks like it's with the x. So it looks like a plus 1, but we're really going to go to the left 1. So, alright, so I've shifted my points. It's those green ones. Hopefully you're not colorblind. And then I'm going to connect those. Remember, this is a growth, so it means that the right side is going away from the asymptote, which means the left side should be coming close to it. So, growth means right side goes away, decay means the left side gets close. And we're done with those. Let's try a couple more. Alright, I'm going to rewrite this. I've got y is equal to 4. Instead of writing e, I notice that the exponent is negative, so I'm going to write 1 over e to the x minus 3. So since I have 1 over e, that's going to make this a decay problem. So this time the right side should be getting really close to the asymptote. Domain negative infinity to infinity. Asymptote y equals -3, and a is positive, so the range, this will be above the asymptote, so this will get close to -3 and then go up forever. Alright, I forgot to graph there's my asymptote. Alright, we need some points. I am, again, going to graph a parent function because there's going to be shifting. Really, the only shifting that's going to happen is from that asymptote, it's going to go down 3. So, my parent function, let's see, I'll do it in this darker color, is y is equal to 4, 1 over e to the x. So I'll plug in 0. Anything to the 0 power is 1, so even if it's 1 over e. So 1 times 4 is 4. There's my first ordered pair. And then the other point I usually like to pick is I like to plug in 1. Again, use your calculator on this. 1 over e to the first power, was that like about 0.3 something, 0.4? And then times 4, I got, hang on, about 1.5. It was like 1.47. So I'm going to plot that point. Alright, now remember, those aren't really the points that I want. I have to graph the down 3. So take both of those points and move them down 3. Remember, this is decay, so the right side should be getting really close to the asymptote. The left side should be going up. Alright, let's try another one. The next one here says y is equal to -1. There's a -1 there. Since it's e to the negative exponent, I am going to write 1 over e. But actually, before I do that, I'm going to kind of stop. There is an issue with this problem. This really says -e, I need to factor out a -1 because there's two things here. So I've got a -1 x minus 2. So if you ever have a negative sign in front of, like here we've got that negative sign, in front of a, more than one term, you need to factor it out. So that's a biggie there. So when I'm rewriting this down, I'm going to write -1, 1 over e to the, we don't need the -1 anymore, x minus 2. If you don't factor out that -1 like I did up here, then your shifting is going to be all messed up. So if you look now, the shifting actually is going to go to the right 2. Where if you look here, it kind of looks like you would have gone left 2. So really be careful with that. Put a star by it, put a mark by it. Alright, domain, -infinity to infinity. Asymptote, there's actually nothing added out here. There's just a +0, so the asymptote's y equals 0. The range, hang on, had to graph my asymptote. Alright, the range, since a is negative, the graph's going to be below, so it's going to be -infinity to 0. Alright, let's get some points. I'm going to graph the parent function y is equal to -1, 1 over e to the x. And then the last thing I'll do is shift it right 2. So that'll be the last thing that I do is shift it right 2. Got stars all over the place. Alright, my parent function, if I plug in 0 for x, anything to the 0 power is 1, so I've got 0, -1. If I plug in 1, I'm going to have to use my calculator because these numbers aren't so pretty, I get 1 about -0.4. Alright, these graphs are tiny. That wasn't very easy to plot. Now what I need to do is take both of those points and move them to the right 2. Alright, we never really said what this was. It's 1 over e, which makes it decay. Decay means it's going to get close to the asymptote on the right, and it's going to go far away on the left. And there's my graph. Decay is getting close to the asymptote on the right. Alright, so now we're done with graphing. Let's try a couple word problems. So, compound interest. Hopefully you understand, if not, interest is like when you're gaining money, when you're earning money just by having money sit in the bank. So, compound is how many times they're going to determine how much interest to pay you. So let's take a look at some of these variables and figure out what, just kind of define what they mean. Alright, so P is the initial amount, it's our starting amount, sometimes called the principal. R is the rate, we're going to change the percent to a decimal. N is the number of times compounded per year. So like if it says monthly, it'll be 12. If it says daily, it'd be 365. And then T is the time in years, how many years. So first example here, you deposit $5,500 in an account that pays 3.6% annual interest. So right away, I know that my starting amount, my principal amount, is $5,500. I know that my rate is 3.6%, which means it's 0.036. You have to move that decimal back twice or divide that by 100. Find the balance after 3 years, so T is 3, if the interest is compounded monthly. So that's my N. There are 12 months in a year, so it's going to be compounded 12 times per year. All I need to do now is plug these into my formula and use a calculator. So A equals 5,500, 1 plus 0.036 divided by 12 raised to the 12 times 3, raised to the 36th power. Alright, really stop this, go get a calculator, plug this in, because this is the stuff that you need to plug into your calculator. You should get, and again this is money, so you should get in your calculator $6,126.27. If you need help plugging that into your calculator, definitely ask me when you see me next. Alright, let's try another one. Alright, the only difference here, really, if you'll notice, that capital A is our ending amount, P is our principal or our initial amount, R is rate again, T is time in years. Notice there's no N. The reason there's no N is because this is a continuously compounded interest, which means it's going to be compounded continuously. I know this sounds kind of dumb, but E is what's going to help us determine that, and E is a number, 2.7, so obviously we wouldn't plug anything in for that. So you deposit $3,000 into an account, so that's what you're starting with. You're starting with $3,000. So P is $3,000. That pays 3.5% annual interest, so my rate is 0.035. Compounded continuously. So as soon as you see that word continuously, you know that you're going to use E, and you're not going to have to figure out what N is. What's the balance after 7 years and 4 months? Okay, here's the fun part. T is equal to 7 years and 4 months. Well, there's 12 months in a year, so 4/12. Reduce this to 7 1/3. 7 1/3 is going to be 7 times 3 is 21, plus 1 is 22, so 22/3. You can't change that to a decimal because it would be a very ugly decimal and you'd have to round it. So we need to use 22/3. Alright, now we just need to plug it into our formula. So A, my ending amount, is 3,000. E, remember E is just a number, raised to the 0.035 times 22/3. Again, this is all calculator work, so all you're going to have to do is grab a calculator, be very careful, check to make sure you can get the same answer that I'm getting, $3,877.84. Alright, please go ahead and practice, or try the buzz lesson that goes along with this, and I will see you in class.